Hello guys and welcome to Freebird's Crew and welcome to 75-day Hard Generative AI Learning Challenge, and this is day 12. And in this video we'll learn about the attention mechanism. This is the LLM stage 1, so just keep it up and we will learn about the generative AI in the next 1 or 2 months fully. Okay, so in this video I will tell you about how it's better than the other methods, and we will also explain the complete working with help of the Python and the transformers as well. Okay, so just watch my previous 2 videos of day 7 and day 8 because these are the prerequisites, because in these videos I explain about the LSTM, bi-directional LSTM along with the window based or the frequency based methods to build the word embeddings as well. Because in this video we will also discuss about the word embeddings and how attention mechanism is better than all of them. Okay, so let's start with our first thing. What are the limitations of the other models? Well, the very first thing is that traditional RNN and LSTMs often struggle with capturing information over a long sequence due to vanishing gradient problems. Okay, they cannot capture the long range frequencies or long range sequences as well. But attention mechanism mitigate this issue by allowing the model to selectively attend to relevant part of the sentence or a sequence and give importance to them. Okay, and the fixed size context windows, as we already learned in our day 7 or 8 videos of the word to vec, where we use the fixed size windows, might lose information in the sequence of varying lengths. Okay, because we have to fix the window size of 2 to 3 to 4. Okay, but attention mechanism adapt to the input length dynamically. Okay, so it allows the model to consider all the relevant information. So that's why attention mechanism is better than all the methods we learn until now with respect to the word to vec, n-grams, globe, every method is that. Okay, so now what is attention mechanism? So attention mechanism is a mechanism in neural network that allows the model to selectively focus on different parts of the input sequence when making predictions. Okay, so instead of relying on a fixed size context window, attention mechanism dynamically adjusts the importance of each input element based on its relevance to the current step in the sequence. Okay, so it will give you the best importance to the word based on the context. It really understands the semantics of your sentence or your text as well. Okay, so now let's talk about the key components of attention mechanism. The very first component is query, key and value vectors. These 3 vectors are the main part of attention mechanisms. For each position in the sequence, these 3 vectors are computed from the input sequence to generate a attention score. Okay, if you see this image here, I pass down my x, there is a input, and then these 3 vectors are getting calculated, and then we'll get our attention score here. Okay, so the attention score are calculated by taking the dot product of the query vector of the current position with the key vector of all the positions. Okay, so this is how you get the attention score, and we will make the softmax and weighted sum of that attention score, converting them into the weights. Okay, the weighted sum of the value vector using the attention score as weights produce the output for each of the position. So we'll know that how this is important for our embeddings scenario. So in this way, this attention mechanism is building the embeddings. Oh guys, okay, so now let's talk about the query, key and value vector in detail. So the query vector represents the current position or the context for which attention scores are being calculated. Okay, so if we have a sentence, then if we choose a position of a certain word, then that is the query vector. Now talk about the key vector. So key vector provides information about other positions in the input sequence, helping the model to understand the relevance of the current context. Okay, because if the query vector select a certain word, then the key vector will provide the information about the other word which are around that selected word. Okay, and similar to the query vector, the key vector is computed through a linear transformation of the input sequence. Okay, and the value vector contains the actual information at each position in the input sequence. Okay, the query and the key vector will be just the pointers to that current location, but the value vector actually contains that position or the actual information. It is also derived through a linear transformation of the input sequence. And if you want to know more about the query, key and value vector working with the like great animation and all the kind of things, please watch this video in which I explained the large language models with along GPT4 architecture as well. Okay, in this video you will have a complete animated visualization about the query and key vector working as well. Okay, so here is the code of attention mechanism that I just created from it is completely from the scratch as well. And here we have a attention layer as a class, and which has the attention layer, and then we build our three vectors, the query, key and value vector, with the weighted names as well, their shapes and their initializer as well. Okay, and then I add this into my attention layer, and then I just build a dot product of these three vectors, and then apply the softmax function to calculate the attention score, and then also apply the matmul function, that is the matrix multiplication function is there, so that my attention scores are multiplied with the value vector here. Okay, then I will get our output as just I explained in the previous slides. Okay, so this is how you build your attention layer, and then I just put this my attention layer in my neural network here and train my neural network. Okay, so this is how you train it. And when you are trying to generate the text kind of a task as well, you can also generate it with this kind of a code. So now it's not getting to generate completely. If I just show you here, I just run this first. Okay, and then I run my generate output code. We'll see it just only generate the Romeo here. Okay, it will not generate all the text because it is not yet completely built out from the scratch or completely optimized. Okay, so we need to optimize it so that it will get used for generating the text. But this is how you can build a attention layer from the scratch. Alright guys, let's talk about that attention mechanism comparison with the other methods. So we know that about the RNN, LSTM and GRU. Okay, these models have fixed size context windows, making it challenging to capture the long range dependencies effectively. Okay, we know that the LSTM and the bi-directional LSTM can approximately handle those long range dependencies, but they don't capture at all in that much effectiveness. Okay, but the attention mechanism dynamically adjusts the focus on different part of the sequences, allowing for better handling the long range dependencies as well. Okay, so if we talk about the comparison between the attention mechanisms and other methods, so the first method is count based method. So the traditional methods based on the counting occurrences of each word may struggle with the capturing of the semantic meaning and the relationship and dependencies in the sequences as well. And on the frequency based methods, these methods might not capture the common patterns and also lack adaptability to the sequence variations as well. And if we talk about the fixed window based methods, these methods have a limited scope and they cannot capture the long range dependencies. But attention mechanism actively focus on the relevant part of the sequence, making them more flexible and capable of capturing the complex relationships as well. Okay. So here we just see the comparison between the RNN, LSTM, GRU versus the transformers algorithms as well. Okay, so I first import all the necessary libraries that I just need along with the tokenizers and the head of the attention mechanisms and build these kind of sequential model, and also we have the comparison models here. Okay, the first I get the data, it is a Shakespeare text, and then I tokenize it, encode it, and also get the sequence length and can build our sequences here. It is just a simple Python code, guys. You can easily get it online as well. Okay, then I split my input, okay, and then my target as well to build a complete data set here. Okay, so this data set has a buffer size of 1000 and a batch size of 64, so that it can be used to train our these all kind of algorithms here. Okay, and then I just build a simple model for each kind of algorithm here for RNN, LSTM, GRU and GPT-2 model, and then compile those models and then train those models. These models are getting generated now, and then we need to train them. Okay, so as you see here, these models are getting trained here. It will take like some amount of time, like approximately 10 minutes or 15 minutes as well. But after that, when you use these models to generate the text here, okay, you put a name here, and for that name it can generate the text after this word Romeo. Okay, and after this word you will see the output of each of these words, and you will be able to understand why the GPT-2 text generation abilities are better than these all the models we have. Okay, so in that way you will understand why these models are better. Okay guys, okay, let's go to the next thing that we have here, that is called the different types of attention mechanism and self-attention mechanisms. The very first is soft alignment. So attention mechanism provide a soft alignment, assigning weights to different part of the input sequence. This softens allows for a smooth transition between the input element, reducing the abrupt information loss. Okay, so if you have this kind of a soft alignment in your attention mechanism, then the information could not be lost, or it will get proper attention for all the words in your sequence. Okay, then we have the weighted sum. The input is computed as a weighted sum of the input elements, where the weights are dynamically determined based on the relevance of each word to the current context and on the basis of the attention score that we already discussed. Okay, now about the different types of attention mechanisms we have. The very first is content-based attention. So the idea behind it to focus on the parts of input that have similar content to the current context. Okay, so it typically involves computing the similarity between the current context vector and the each input vector. So in that way you can get a similarity matrix between these two inputs. Okay, and the second is location-based attention. It focuses on the specific positions in the sequence. Okay, it assigns weights based on the position of the input element in the sequence. So this is like basically used in our nowadays. And then we have a global attention that consider the entire input sequence for every decoding step. Okay, so the compute attention score globally across all the element in the sequence that is currently used by the ChatGPT and all the large language models we have. Okay guys, okay, I hope you completely understand these different type of attention mechanisms. So the next thing is transformers. So now if we talk about the transformers here, then we can say that the transformer model consists of the encoder and decoder. Okay, and the encoder, it comprises of multiple identical layers, each with two sub-layers. The first is multi-head attention mechanism and a position-wise fully connected feed-forward network. Okay, so that it can calculate the attention score for each of the input that is given to it and encode it. Okay, now the next thing is similar to the encoder, but includes the additional multi-head attention mechanisms to attend the encoder's output. So when the input got encoded via the multi-head attention mechanisms, it get decoded here. So that we need also multi-head attention mechanisms here as well. So multi-head mechanisms, it means that it can do a many kind of tasks with the single transformer. You can also do the text summarization, text generation, text translation. Okay, so when a neural network or a transformer can do multiple tasks, then it is called as multi-head attention mechanism transformer. If it is doing only a single task, then it is called as single head attention mechanism transformer. Okay, then we have a positional encoding. So added to the input embedding, to provide information about the position of the each element in the sequence, then we have this positional encoding so that our transformers can understand the importance of each position in the input sequence. Okay guys, okay, so let me just explain you one more code here that is called multi-headed attention. So I already explained that what is multi-headed attention, when your model can be able to do more than one task of text generation, of machine translation, or anything like that. So in the code here we have this sentence, and I will show you how the multi-headed attention can give attention to all of the words in this sentence. Okay, we build our vocabulary here in the form of a dictionary. We build a sequence and we get the max length of 10, and we just build a sequence with the help of Keras library here, and then we build our multi-headed attention layer here with the number of heads is 2 and embedding size is 4. And when we build our model here and try to get the summary here, and then with the help of this simple plot, I will show you how the input just looks like. So we have this input layer, embedding and multi-headed attention here, and this is how your input looks like. So you can see there are like, you can change these axes from this point of view, and you can change with the help of this graph size or with the help of this VV max and V min, so that you can get this more positions. So it shows that all the words in this sentence have the equal kind of attention. There is no word who have more attention, there is no word who have less attention. But if you just use a more kind of a larger text corpus here, then this kind of attention scores can be changed, and you just see here that for each word their attentions getting separated as well. Some words can get attention of 1, some word can get attention of 0 as well. Okay, so in that way this multi-headed attention mechanism will work. Okay guys, okay, so I hope you guys completely understand about the multi-headed attention mechanisms, along with the comparison between all the attention mechanisms as well. So in our next video I will show you how to do multiple tasks like text generation, text classification, translation, summarization with Hugging Face transformers. Okay, so we will do everything with those libraries, with those open source transformers as well. So just be with it. And if you want to know more about prompt engineering, data science algorithms, along with the financial data analysis, you can watch my videos on the YouTube and also read my blogs on Medium. And we'll meet in our next video. Thank you so much.